Hello everyone, today I'm going to explain or clarify a little video I've uploaded a few days ago where I showed a few renders and calculations of a little side project of mine. Uh, you're seeing it here right now. If you saw this before, you've probably seen that video. And what this actually is a hypothetical little project that I've just been thinking about for fun. The idea would be a unmanned experimental aircraft that would fly at supersonic speeds using only an electric engine. Now there are several ways to do this. It's of course very impractical. It's only an experimental aircraft. It would fly for about 2 minutes, break the sound barrier, and then slowly fly back down and land. Of course, it was kind of questionable if electric motor supersonic flight is even possible yet. I've concluded it's possible but extremely impractical at the current stage of technology. You'd need a very slim, very pointy airplane that is mostly engine and battery and maybe 1% actual payload, so it would only fly supersonic for a few seconds, but it's interesting experimentally, and with advancing technology, of course, more might become possible. And I'm probably never going to build this. It's just a hypothetical project for fun to think about and design, but hypothetically, the idea that it could be built is, of course, part of the design. It would be driven by an electric motor and an impeller that spins really fast. There are, of course, different ways to fly supersonic with an electric propulsion system. Of course, you could just use essentially a turbojet or turbofan engine, and instead of using a chemical fuel combustion to heat up the combustion chamber, you could just close the combustion chamber, so not inject any fuel, just let the air flow through and heat it up using electric heating. So you could modify a turbojet engine. Of course, there would have to be a few little other modifications to keep it working well, but you could design a modified turbofan engine that would be powered electrically by electric heating. Well, this is actually supposed to use electric motors and basically a really tough, really small little propeller or impeller with an actual stator behind it, because it's got really high pitched blades. Because if you want to fly supersonic, the rotor already has to spin really fast, and if you had less pitch in the blades, you would needed to spin even faster, and at that speed it would pretty much disintegrate. And since it has a lot of pitch, it also needs these stators to get the airflow without twisting through the rest of the tube. It's very, very small, very thin, very pointy. It's supposed to be about 4 meters long, the tube being about 70 millimeters in diameter and a wingspan of about 60 centimeters, so it's just a little experimental drone plane. It would weigh about 15 kilograms, only one of which would be like payload, something like a small camera or something like that. Of course, hypothetically, you could scale this up to carry one person, but it would still be relatively useless for any actual application. It would just be an experimental plane, and at this point, it's just a hypothetical experimental plane, so even less actually useful. But it's really interesting to think about, and the idea is to use several long, thin motors get an overall power output of just above 20 kilowatts. And, well, since it's very, very thin and very, very small, it could then break the speed of sound for a short amount of time before the batteries would be just about to overheat, and then you already have to reduce power and go back below the speed of sound again. But it would be really interesting, and it would pretty much be the first electrically driven supersonic vehicle. Uh, though the video actually shows two different iterations. The simulations show earlier iterations, the renderings show a slightly later iteration. Not too much has changed, but the wing design mostly has changed a little bit. And otherwise, I just basically stretched it a bit longer to make more room inside without actually making it thicker or giving it more wind resistance. That's simply because during designing the systems and actually designing the motors to drive this, I kind of ran out of space inside it, so I needed a little more space, so I had to stretch it a little longer because the earlier iteration was just designed from something I just quickly thought up and then got to SolidWorks and made a basic shape, and that had just enough room for the batteries and the motors, but nothing else. And of course, it's gonna need a little more control electronics to actually work. It needs a landing gear that somewhere has to fit into the fuselage, so I had to make it a little bit longer to actually fit. I've also made the structural design with a little more margin of safety to actually be sure that it would probably work rather than it should kind of work. Now, I hope this was somewhat interesting, and thanks for watching.